Let's start by taking a look at the properties of water and how it interacts with fibers. We're going to use water in place of sweat since sweat is 99% water. On a molecular basis, water is known as H2O. This means that a water molecule has 2 hydrogen atoms and 1 oxygen atom. The smaller hydrogen atoms carry a small positive charge, while the larger oxygen atom carries a much greater negative charge. Scientists say that water is polar because it has a positive charge on one end and a negative charge on its opposite end. One rule of science is that opposite charges attract, so water molecules tend to stick to each other because their oppositely charged ends are attracted to each other. This intermolecular attraction between water molecules is known as cohesion. Cohesion is why water sticks together to form drops rather than spreading into a thin, flat, even layer. Even though water molecules carry both positive and negative charges, the much greater negative charge of the oxygen atom overpowers the smaller positive charges of the hydrogen atoms. This gives water an overall negative appearance to other molecules. Wicking fibers are said to be hydrophilic, or water-liking, because they have mostly positive charges on their surfaces. This attracts the negatively charged water molecules. Water's attraction to a fiber's surface is called adhesion. It's the combination of water's adhesion to positively charged fiber surfaces plus the cohesion between water molecules that produces capillary action, or what you simply know as wicking. When single fibers are combined into threads and then into fabrics, they create many small spaces known as capillaries. Here are actual examples of wicking or capillary action taking place within a thread of wicking fibers and on a piece of fabric. With the help of 3D animation, we can see how the negatively charged water molecules adhere and spread out along the positively charged wicking fiber's surface. At the same time, the cohesive forces of the surface water molecules pull the other water molecules along through the capillary. The special properties of Drimax do not allow it to attract or hold on to moisture. Because it doesn't get wet, you don't get wet.
Here's just one more example of how much Drimax hates water. For more information, log on to DrimaxSocks.com.